Hi everyone, welcome to the second video of UCCE. I'm making this video on your request. I see some comments for making more videos and here I am making it at around 12 am in the night. I was running little busy from couple of days, but I have managed to do this video. With no further ado, let us get started. Today we will be looking at the ICM components and the database. So as you know, ICM components include router, logger, PG, and AW. In Cisco collaboration, there is a product called as CUCM. And this CUCM is basically a call control product. Whereas the ICM or the UCCE, this is the call distribution product. CUCM, when I say it's a call control product, it can register a phone, it can route the call, it can do the digital analysis. So these are the things that the CUCM can do. So how different the CUCM is compared to the ICM, or how the ICM does more things than the CUCM. If you take, for example, in CUCM, we can define something like hunt pilot, then the hunt list and the line group. And in the line group, we can give multiple numbers so that the calls can go to multiple extensions. The same thing is done by the ICM, but in a better way. So how in a better way it is going to do it is, when a call comes to the hunt pilot number, it just routes the call to the agents by using a distribution algorithm. Either it can be simultaneous, or it can be round robin, or it can be some other logic. Depending on that, it will route the call. But without knowing if the agent is available to take the call or not, it just routes the call. But in the ICM, it is not the case. ICM exactly knows whether the agent is available to take the call or not, whether the agent is available, whether he is in wrap-up state or he is in not ready state. So the ICM knows that before sending the call. So that is the major difference between the call manager and the UCCE. When the call comes to the UCCE, it will be in the router's memory. A router is the brain of the contact center, where it does all the decision making. The router decides the call routing, and when a call comes to the contact center, it will be in the router's memory. And router runs the script in the background, that's the business logic. And in the script, if there is a node like Q2 skill group, then it looks for the active agents. So router has visibility to the contact center through another component that is called as PG, peripheral gateway. And this peripheral gateway exactly knows whether the agent is available, not ready, whether he is in wrap-up state. So all the agent state management is done by the PG, and PG feeds this live information to the router's memory. When a call comes to the contact center and it queues against the skill group, the router looks for the existing agent who is available, and then it routes the call to the agent. But in the previous example, in this case of CUCM, the call is directly given to the agent whether he is available or not to take the call. It is just routed the call. But in the second scenario, it is not like that, where in the second scenario, the agent availability makes a difference, and also router takes two things here. One is the business logic, that is the script, and the real-time view of the contact center. Using these two things, the router makes the decision. So that's why router is called as the brain of the contact center, where router makes decision depending on the real-time view of the contact center and the configuration that it is having. So what we understand is router is the brain of the contact center. Why it is brain of the contact center? Because it takes a routing decision based on the two things, that is real-time view of the contact center plus the configuration information that it gets from the logger. So we'll talk about the logger next, and this is the critical component of the contact center. Next, let us look at the logger. And one more thing about the router is router has memory. It does not have a database. If the router just switch on, and suppose if you switch off the router, the memory is gone. Whereas the logger has the database. It stores the database. And the logger has the SQL database. Logger, it's a software that gives the access to the underlying SQL database. It's in a structured way, it gives the access to the underlying SQL database. And router has a memory, as I have said, and logger has a database. Why the router has only memory? The reason behind it is for the fast processing. Logger, it has a database, as I have said multiple times now, and it stores the data. It stores the configuration data, scripts, historical data. We will talk much about the database in the next session. So logger, every logger has a router. As you know, UCCE can be deployed in a simplex manner or else in a duplex pair. In simplex, you have only one side of the router, logger, PG, AW. Whereas in the duplex, so you have two sides, that is router on A side, logger on A side, PG on A side, and then AW on A side. Similarly, you can have router on B side, logger on B side, PG on B side, and AW. Either they can be separated over the LAN or the WAN. And also, the router A communicates with the router B, and they are the duplex pair. And the PG is also a duplex pair, whereas the AW is not a duplex pair. Router A and router B, so they are in sync, they are active. Similarly with the PG, they are also a duplex pair. So router A and router B are in active, and when a call comes to the contact center, so that call is present in both router A's memory and router B's memory. If anyone goes down at that time when the call is being served, it is taken care by the other side of the server. The fault tolerance is very beautifully designed in UCCE so that there is minimum downtime in the time of outages. Once the call is being served, so it is in the router's memory, and when the call gets disconnected, so this information will be logged into the logger's memory, the database, logger's database. So all the information is committed into the logger's database, and as I have said, logger has config data, scripting, and other configurations and historical data. Logger stores the data for 14 days is the retention period of logger. It depends on the database that you would be creating in the ICM DBA tool. By now, you would have known what is a router and what is a logger. Let me explain you a little bit more here about the router and the logger. Router has memory and logger has a database. And router makes the decision and he's the brain of the contact center. Every side of the router has its respective logger. So router A communicates with the logger A, router B communicates with the logger B. Router A and router B are in sync, we know that by now. When a call comes to the contact center, as I have told you, the call will be present in both routers' memory. Once the call is disconnected, the respective router will update that information to their loggers. Does logger communicate to each other? No. Logger A never communicates to logger B, but except in the recovery process. So what is this recovery process? When I suppose in case the logger A goes down and the call is coming, okay, so that information will be in the router A's memory and router B's memory. Now the state is the logger A is down and the call gets completed, and this information router B sends to the logger B and it commits into its database. But since logger A is down, so router A will not be able to commit the information to the logger A. And once the event is passed, then that information is not in the router's memory. So in this case, after some time, logger A comes back up. Once it comes back up, it does not have the information about the call that has passed. In that case, when the logger initializes, it connects to the logger B to check how much historical data logger B is having. In case if it is having more keys, that is, suppose if it is having the data from 1 to 7, it looks into its database and it is having tables from 1 to 5. By looking at some keys, it will come to know how much data it is having. If the logger B is having more data, then logger A asks for the state transfer, and then the logger B starts the state transfer and it makes the data equal, the keys are equal. Once the keys are equal, then it stops and it never communicates again. So it will not happen like router B communicates to the logger A on the other side, or router A communicates on the logger B on the other side. So these are some of the basic concepts that is required to understand the router and logger. As you already know, so router and logger, they are called as the central controller. Router and logger pair, so they are called as the central controller, right? And these routers and loggers, these are on the Windows platform. Unlike the CUCM, that is on the VOS platform, voice operating system, that's Linux based operating system. Every component has to be installed on a separate Windows box. If you have a 2000 agent template, so then you can install the router and logger in the same Windows machine, and that is called as logger. When we touch the installation part, so I would be explaining you how exactly the router is installed and the logger is installed. But let us limit ourselves to the router and logger discussion today. I hope you have understood with these examples what is the function of a router and what is the function of a logger. Just to summarize, router is the brain of the contact center and it gets the real-time view of the contact center through the PGs. PGs are the eyes of the contact center, which gives the real-time view of the contact center, like how many agents are available, who is in wrap up state, not ready state, and then the router makes the decision based on the configuration that is having and the real-time view. The basic thing of any contact center solution is nothing but serving the contact in a best possible way. Sorry, I think I did a mistake here. Serving the contact in the best possible way is every contact center solution goal. So nowadays we have a lot of cloud contact centers, omni-channel contact centers, right? So we have email, chat, and social media platforms all on a single portal. In a single portal, you have voice, messaging, social media platform integrations. So everything on a single channel. Even the video also can be bought on the same portal. So that's why the name omni-channel contact centers are very popular nowadays. As you can see in the picture, so we have a router and a logger, and we have something called visible network and private network, which we can talk in some other session. I wanted to keep this video very short, but since there are a lot of things to cover, so it's stretching a bit more than what I expected. So we have learned till now like the router and logger, and there is a NIC which was supposed to be installed on the router box, but these are very old ones, and no, we are not using anymore like NICs. There was a concept called pre-route and post-route, where the carrier call is completely delivered to the contact center or it holds the call. Depending on that, we had pre-route and post-route. So no need to worry about this. No organization is using this NICs. And this ICM basically was used by the service providers to make the intelligent call routing. Back in the days, it was also called as ICR, Intelligent Call Router. And Cisco acquired it through Geotel, as you might have already known this. Let's go to the other component now. That is AW and the PG. Let's take a glance on this. The router process is the brain of the contact center and is responsible for making decisions, right? The real-time view is created by the router gathering real-time data from the peripheral gateway, that is the PG, and combining this information with the configuration data retrieved from the logger database. So router in one hand has the real-time view of the contact center. On the other hand, it is having the configuration power that it gets from the logger database, and it makes the decision. And the logger controls the access to the underlying SQL database. So logger basically has a SQL database, and on the logger we build the templates for the historical data and then configuration data. And the logger is also responsible for replicating data to the HDS server. So this we will learn later. AW is basically where we do the configuration. Administrative workstation. So administrative workstation, it has a database copy from the logger, and AW receives updates from the central controller to keep the database in sync. AW is not a duplex system, you need to know this, and if the AW goes down, it does not affect the routing operation, because the routing mainly depends on the router. AW is not a business critical, so you can deploy AW on one side, so that should be fine. AW, as I have said, it is used for the configuration purposes. And you can deploy AW in multiple flavors. You can deploy AW as a configuration only AW, or you can install it as AW and HDS. HDS is the historical data server, and it can be installed in the same Windows machine where the AW is installed. AW is for the configuration purpose, and also it has the real-time reports. And HDS, it is, as the name itself says, historical data server. It has the historical reports or the historical database. You can also install as AW, HDS, DDS in a single Windows machine. DDS is not a database, but it is a table inside the HDS. You can install AW and HDS in all these flavors. Depending on the user template, you can deploy these components. For example, if you take the 2000 user template, you can have AW, HDS and DDS like in two numbers for each side. You can have side A and side B. If you go for a 4000 agent template, then you can have 2 per each site. Like if you have 2000 agents, side A, so this much side A, you have AW, HDS, DDS on side A and side B. Similarly, if you go for 4000 in a single side, you can have these in two numbers. That is the standard, but you can follow as per your requirement. And when we do the configuration in AW, you need to log into the AW box, and there is a folder called as AW tools. There is a component called as UCCE admin tools. So then you need to choose the configuration manager, and in the configuration manager you do all the configurations. Basically AW is used for configurations and storing the real-time data. Now let's see the PG. Peripheral gateway is the eyes of the contact center, as I've already told you. So this PG gives the real-time view of the contact center. And PG provides an abstraction layer between the central controllers and the peripherals to which the central controller is connected. This PG connects to the peripherals, that is nothing but the CUCM or the Avaya Aura or aspect call managers. And also the PG can connect to the VRU units like the CVP or the IIPVR or any third-party VRU units. And this PG translates the messages from the VRU way of understanding to the central controller. Central controller, as I said, it is nothing but router plus logger. So PG acts as an abstraction layer between the peripherals and the central controller. Peripherals or the routing client. When you say routing client, a routing client is the one that can send the route request to the central controller and receive a response back. That thing is called as a routing client. For example, the VRU, so we have CVP server. CVP can send a route request directly to the central controller and receive a response back. So CVP is the routing client or the peripherals. So if you want to translate the messages of peripherals to central controller, then you need PG. There are four kinds of PG, that is agent PG, VRU PG, then we have media routing PG and generic PG. Agent PG is used to connect to the ACDs like CUCM, Avaya Aura or any other call manager. VRU PG is used to connect to the VRU units, voice response units like CVP. Media routing PG are used to connect to social media platforms, and also it can connect to email, chat, enterprise. Generic PG, it is a special kind of PG where in a single PG you can connect to both to CUCM and to the CVP. A single PG can connect to a same type of peripherals. Like if you have a PG configured for ACD, like agent PG, so it can connect to the ACDs only. You cannot connect the agent PG with the CVP. Okay, and PGs for connecting to the peripherals. So it has something called as PIMs, that is Peripheral Interface Manager. If PG is like a hand, PIMs are like fingers. Just like in a switch, you have multiple ports, and the function of these ports is to connect to the other devices. Similar to that, the PIMs are like Peripheral Interface Manager. These are the interfaces, software interfaces that are used to connect to the peripherals. Either it can be CUCM or the CVP, depends on the kind of PG that you are configuring. If you are configuring for the agent PG, then you need to connect to the CUCM. If you are configuring it as a VRU PG, then you need to connect those PGs PIMs to the CVPs. If you are configuring your PG as a MRPG, then you need to connect to the social media platforms like social miner product you can connect, or to the ECE servers you can connect. The special case I told about is the generic PG, where the PG can be connected to both the CUCM and the CVP. Then you need to configure this PG as a generic PG. And this is applicable only for the CUCM and the CVP. We cannot connect to Avaya Aura in the same PG and also a CVP in the same PG. So this can be PIM1 and PIM2. Like this, we can have 32 PIMs in a PG. That means what? So we can connect to 32 peripherals in a PG, but normally in production, 1 or 2 peripherals only connected to the PG. I mean, we utilize PIM1 and PIM2. Let's see some theory that is here. The PG converts the proprietary communication from the peripheral into the protocol used by Cisco. That is nothing but it converts the messages of the peripherals to the language that the central controller understands. The PG is capable of sending route requests to the central controller and also receiving a route response. The PIMs communicate to the peripheral and translate the peripheral proprietary language into UCC understands. So we have several kinds of PGs, 4 kinds of PGs, sorry. Agent PG, VRU PG, and the media routing PG. And media routing PG, as I said, it connects to the multimedia components like enterprise chat and email or social miner. Voice response unit, it is able to connect to the CVP, or earlier we had a product called IIPVR. This slide here shows the diagram for the routers and PGs, how they are connected. You are seeing visible network and the private network in all the slides. We would be covering this in the fault tolerance section in coming sessions. But for now, you can understand that PG is connecting to the central controller, that is router plus logger, right? So it connects through the visible network, that's a public network. If a router connects to a logger, so it does that through a private network. Whereas anything that is central controller connecting to the other components of the UCCE or other components, other third-party components, it is through the public network. So this is basically for the fault tolerance. And one more important thing to remember is PG connects to the router only. PG will never communicate with the logger. PG never communicates with the logger, and PG only communicates with the router. Let's move on to the next slide. So this gives the internal working of a PG, but we would be discussing the nodes and processes in the upcoming session. This session is all about understanding the components and how they function. As you can see, the PG is connecting to the IIPVR, that's a peripheral, and CUCM, again it's a peripheral. These peripherals through PG connect to the central controller, that is the router. Let's move on to the next slide. So PIMS, by now you have understood that it's a software interface. It is used to connect to the peripherals. Each PG can have 32 PIMS. Each redundant pair of PG can support up to maximum of 2000 agents. It depends on the deployment. In UCCE, we can deploy up to 24,000 agents in a single UCCE instance. The multiple PIMS are helpful for scalability and also it helps to communicate with multiple peripherals in the same cluster of CUCM or in different cluster. We can deploy each PIM in a different agent PG as well. VRU PIMs can reside on either VRU PG or in a generic PG, but it has to be Cisco's CVP and CUCM. You cannot mix CVP with Avaya or any other third-party ACD. This is a special case. I will show you the configuration at the end, like what I am talking about. Let's move to the next slide now. There is something called CTI server, that's a CG server, and this normally is installed in the same box as the peripheral gateway. Okay, and peripheral gateway in the same box as the peripheral gateway, but CG is not a duplex pair, and it can be installed in the same box as a PG or in a separate box. But the function of the CG is CTI, computer telephony integration, and this CTI gateway connects to the finis or any other application that requires the CTI. And then we have JTAPI communication. JTAPI communication is between the PG and the call manager, that is CUCM. When you connect a PG with the CUCM, you need this JTAPI communication, the JTAPI channel. So in this JTAPI channel, the CTI events are passed. So how to establish this JTAPI communication? Like we need to log into the same box as PG, open the CUCM, and then we need to navigate to the application section where we install the RTMT. In the same section, we have something called JTAPI gateway, and we need to install the JTAPI and then point it to the CUCM, that is CTI server, and then the JTAPI gateway passes the CTI events into this JTAPI channel. So that's the function of the JTAPI communication. And the CTI, we will get a better picture here. The CTI, this is the CTI gateway part, that's the CG part. So CTI gateway connecting to, in this case, it is some desktops, but it can connect to the finis, and finis connecting to the finis desktop agents. And then you can see here the JTAPI gateway plugin that is installed, which is sitting on top of the agent PIM. If it is a VRU PIM, you can see there is a separate PIM for connecting to VRU. Either it can connect to IPVR or any other VRU product like CVP. And this is a generic PG, as it has got agent PIM and also the VRU PIM in the same box or the same PG. We have a separate section called CTI gateway that can be installed in the PG or else on a separate box. That CTI gateway connects to the finis, whereas the JTAPI gateway connecting to the call manager. And call manager, we have CTI service, and this CTI service talks to the CM service, and this CM service is controlling the phone, and this can be SIP or SCCP communication, and these messages are converted by the CTI servers into CTI service as a CTI events. In a cluster, we can have 8 CTI servers, and why is that is wherever CM service is running, there we need to run the CTI service. In a call manager cluster, we can have 8 call processing nodes. So that is why we can have 8 CTI servers in a cluster, and this CTI server passes the CTI events through the JTAPI channel to the PG, and then it goes to the PIM, and then OPC gives it to the PG agent, and PG agent gives to the central controller, CC agent. So the working of the nodes and processors, we will cover it in the next section, but for now we need to understand what each component is doing. So this was about the PG component. I hope it is informative for you. Let's move on to the next slide now. This NIC, it was used in previous older versions of UCCE. Nowadays we are not using NIC anymore, so let's just skip it for now. But to give a high level overview, NIC is used in a pre-routing context where the call was not completely delivered to the ICM. For example, if a call is coming from US and it comes to the carrier, and then the carrier decides the call has to go to India, and then it goes to the India ICM for call distribution. Like, it takes the logic from the script, business logic from the script, and then call is given back to the carrier, and then the carrier routes the call to the other call center, maybe it is in Singapore. So in this case, the call is not completely delivered to the enterprise, but the call comes back for further treatment to the carrier. So this is pre-route. In this pre-route, there was a software that was used that is called as NIC, and that used to be installed on the router box. This is a software, not the hardware NIC that we use in our laptops. And this software was installed in the same box as the router, and it was used to translate the messages from the carrier to the router's understanding. It was used for translating the messages from the carrier, directly from the carrier to the router. This was the pre-route. So what happens in the post-route? When a call comes from the carrier, the call is completely delivered to the ICM, and then the ICM decides where to route the call, and the call is routed to maybe CUCM, and then the call routes to the agent. But here that is not the case. The call is not given to the internal application where it can route internally, but the call will be given back to the carrier, and then the carrier decides where to route the call depending on the logic that is defined in the script. What logic? Suppose the call center is active at this particular time in Singapore. So to know that, the call is given to the ICM, and ICM, through the logic, it will come to know which agent is available in what call center. So by applying the logic, it came to know the agents are available in Singapore at this particular time. That information it passes to the carrier, maybe in the form of a label, like the agent label. So then it will come, and looking at the label, it comes to know it has to route the call to the Singapore. So similarly, the call will be routed to Singapore. So that is about the pre-route and post-route. If you are not getting this part, so no worries, because we are no longer, many organizations no longer using this. I will stop the video here. It's a long video. I thought to make it short, but since I had to explain a lot of things and I don't want it to skip on important points, there were a few more things that I wanted to explain, but I don't want to stretch. Just to recap, we have learned about the router. It's the brain of the contact center, and it has a memory. If you switch on and switch off, the router memory is gone. router, whatever comes to the router, that information is committed into the loggers database, and logger has the configuration database and the historical database, and its retention period is 14 days. And logger gives the underlying access to the SQL database. So what is database? Database is nothing but rows and columns. And SQL creates few variables, few templates. The logger creates few templates where the data goes and sits into those templates. And then we have AW, which is used for configuration purpose. And then we have PG, that is the eyes of the contact center, that gives the real-time view of the contact center. So that is about the PG. And HDS, that is used to store the historical data, and its retention period is up to 3 years, depending on the database you describe in the ICM DBA. I will take like 3-4 minutes to show you in the lab like what I just explained to you. So this is the router, logger, PG, AW setup that I have done in my lab. I'm just showing you the processes and the services that are installed here. This is a diagnostic portico tool where you can watch the process status and also the services. Every nodes in every component in UCCE is called as a node. So this is a AW node, logger node, router node, and PG node. Every node has multiple processes in it, as you can see here. And by going to the service control over here, you can know what are the processes that are running in that box. This is a lab environment, so I have installed all the components in a single box, but you can install in the production, like you can install all the components in a separate box, or depending on your requirement, you can install it. Whenever you install AW in the server, in the Windows machine, so this is the folder that comes on the desktop by default. If you click on the folder, you can see there is a configuration manager where we would be doing most of the configurations. When you click on the configuration manager, we have tools. In these tools, we have Explorer tools and list tools. For running the PG setup or doing the configurations for the PG, we need to go to the Explorer tools and then the PG Explorer. And in the PG Explorer, you need to retrieve, and you can see the PG is configured. So as you can see here, this is a generic PG that is configured. For understanding purpose, I will just try to add a new PG here, and then I will give some name, test, and you can see the client type over here. Either I can choose CUCM, generic, or the VRU. If I choose generic, I can add both CUCM and VRU in the same PG. For example, I have already created. So if you go to the VRU PIM, so you can see the name of the VRU PIM and some configuration related to the routing client. So this we would be discussing in the next coming sessions, if possible, like how to install and how to make the UCC solution up. I would stop here as the video is getting more and more longer, so I don't think it is good. If the video is short, so it is very good to learn. If you like this video, please comment and also subscribe to the channel for more videos on contact center platforms. And yeah, please let me know that how this video is on the comment section. Thanks a lot. Have a nice day ahead. Bye.